Hey y'all. Okay, so we have done zero exponent rule, the negative exponent rule, and the quotient rule for 12.2. Hide this. Oop. Delete this. Okay. Oh, I'll try to go out. I don't know why it literally won't even let me go out. I don't like it. Okay, so let me delete this too. So now what we're going to do is combine. What I mean by combine is I've got one, nope, that's not one. 1, 2, 3, 4. I've got 4 examples. One ends up with a very large number when you actually evaluate it. I don't have my calculator near me, so I'll probably need to find that to do it. But what I mean also by combine is a problem could actually use all of these different rules that we've learned, and also the rules that we learned previously with our 12.1 videos, which are going to be the other exponent rules. Okay, so I am going to get started. Let's do problem 1. Okay, let's say in parentheses we have 2x cubed over 5. Close parenthesis, raise it to the negative 4 power. Negative 4th power. Okay, so what we're going to need to do is notice that on the outside of my parentheses, I have a negative exponent. I had told y'all that if you have parentheses and like something in a fractional form, what you do is you flip your fraction, and now that changes the sign of that exponent on the outside. Now it's positive. Now what we would do is use the power rule, where if you have terms on the top and terms on the bottom, all being raised to a power, I'm going to feel okay. I'm going to come over here, okay? So everything on the top, everything on the bottom is going to get raised to the 4th power. Y'all, I'm probably not going to actually evaluate this. I mean, you could use your calculators, but just for the sake of time, and because I don't know my calculator is. What I have on the top is a 5. It's going to get raised to the 4th. What I have on the bottom is 2, and I have x cubed. I'm actually going to look at those as 2 separate terms. You could put it all inside of parentheses and raise it to the 4th power. Again, that's just kind of to show you that there's probably an astronomical amount of ways that you could solve these problems, okay? So I'm going to do individually. I have a 2 that'll get raised to the 4th power, and then I also have an x cubed that's going to get raised to the 4th power. If you do not put x cubed into parentheses, it will look like it became x to the 34th, and that is not correct. You do x cubed raised to the 4th power equals. We have 5 to the 4th power over 2 to the 4th power. In your calculator, you can go ahead and evaluate that. 5 times 5 is 25, 25 times 5, and then that times 5, 625. That's what I think. In our denominator, 2 times 2 is 4, 4 times 2 is 8, 8 times 2, that should give you 16. Again, for this problem, I'm not going to actually evaluate, okay? But we do need to look at the rest of our denominator. I have a power rule here, and the power rule that I have is power to a power. I was taught to multiply my powers. So what you do is you keep the base, and you multiply both of those powers together. So you get 3 times 4, which is 12. Okay, so again, evaluated, it would actually have a numerical value for 5 to the fourth, and you should get 16 for 2 to the fourth. And then our variable is going to be x to the 12th. Okay, so let's do this example. For example 2, say we have x squared x to the negative 6, x to the negative 1. So this is going to involve 2 different rules, I believe. What I noticed first is that all of these are multiplying each other, right? Because I don't see an actual operation sign in between them. So that's what tells me it is going to be multiplication. And I know that I have a product rule. The product rule states if you have the same bases multiplying each other, it can be plural, what you do is you keep your base and you add your powers. So this would be 2 plus a negative 6 plus a negative 1. Y'all, this could also be written as 2 and then minus 6 minus 1. Okay, so I'm going to keep it as that previous one since the rule actually says add your powers. I think hopefully that should make, a good amount of sense. Now let's actually do that math. We have x. Okay, if you do 2 plus a minus 6, those signs are different. So what you do is you subtract and you keep the sign of the larger. Now what do I have left? Plus a negative 1. So I have x and then negative 4 plus negative 1. Those signs are the same. So you add them together, you keep their sign. And then what? Hopefully you didn't say you're done, right? Because there's no way this could be an answer because correct answers never have negative exponents in them. Because this is not in fractional form, it's more in like whole number form in a way, if you kind of get my drift. It's in a denominator, right? That's technically what I mean. Because this is not in a denominator and it has a negative exponent, what I do is I bring it down to the denominator. I write it in the denominator, and that actually is going to, folks, change the exponent from a negative to a positive. That would be the final answer. So that used the product rule and the negative exponent rule. Okay, for problem 3, let's do this. Okay, so do a big fraction bar. That would be easier to say first. Do a big fraction bar, and then now let's do, sorry, I'm looking at my problem. Oh, that's why. Okay, sorry. I have it written here, and then I did a little note, and that note kind of confused me for a second. But that note was for the previous problem, which had said to flip first, not this one, but actually this problem number 1 was written above this problem, and I had written that you flip first. That's why I got confused. It does actually apply to this problem as well, but the rest of my notes, they didn't match. Okay, so we get a fraction bar, and in our parentheses, we have 4m close raised to the negative 3 power, denominator 3m close raised to the negative 4 power. So I almost want you to cover up the screen from the fraction bar down. If you look at that 4m and then all raised to the negative 3, it's in like the numerator, right? It's in the top. So because that negative 3 is there, what I would do is bring it to the bottom. So this gets brought down. And then in my denominator, if it's negative in the denominator, then it's going to be positive in the numerator. So this is also a flip, or we're going to switch them. Okay, so what I get in parentheses is 3m all raised to the fourth over 4m all cubed. So now what I have is that power rule, which said if you have multiple things inside of a parenthesis and the whole parentheses being raised to a power, then each individual thing inside of your parenthesis gets raised to that power. So our 3 gets raised to the fourth, and our m gets raised to the fourth over, apply the same power rule on the bottom. Our 4 would get raised to the third power, and our m gets raised to the third power. Okay, y'all. I'm going to come right here. Okay, so when you look at those, just like the numerical values of 3 and 4, I couldn't apply a rule there, right? Because those are not the same bases. So I'm just going to write them. There's nothing I can do with them. They're just going to stay. And my 3 is being raised to the fourth power. My 4 is being raised to the third power. Question. Your m's, the one on the top and the one on the bottom, those are the same base, right? So that means I can do the quotient rule on that right there. And what I do is I keep my base and I subtract my powers, right? The way you do that is you actually are going to use the numerator, subtract the denominator's exponent on our m, and then now let's evaluate this. We have 3 to the fourth over 4 cubed. Sorry, ran out of room. Look at your m to the 4 minus 1. Well, m is going to stay m. 4, why did I say minus 1? See, I did it again. When I know where I'm going, my brain just says the number. M to the 4 minus 3. So looking at that subtraction, their difference would be a 1, which means I would have m to the positive 1 power. So it doesn't have to go anywhere. It doesn't have to go to the bottom. It literally can stay up top. And that would be my final answer, y'all. Again, I'm not actually computing this. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 would be 2, 4, 6 plus 21. 6 and 2 is 8, 81. M. And then 4 cubed, we have 4 times 4 is 16. 16 times 4, that gives me 40 and 24. So 20 and, no, what did I say? 60, why did I do that? 16 times 4. Okay, 40 and 24. 40 and 24 is 64. Sorry about that, y'all. There we go. So homework answer, exam answer. Sometimes you won't have to evaluate it if your exponent's too high. So I just went ahead and evaluated those, y'all. In my head, pretty sure that my mental math there was correct. Okay, so this one I'm not going to evaluate because the denominator should end up equaling 1,728, and I couldn't mental math that to save my life, unfortunately. So let's do it. This is going to be example 4. In parentheses, I got a fraction, y'all. Numerator is 3x to the negative 2. Denominator, 4 to the negative 1. Y cubed, all raised to the negative 3. I'm actually going to kind of work my way out and then go in. So I would look at the negative 3 on the set of the parenthesis, right? Like I want to do that one first. And I know that if I have something that looks like this, what I would do is flip everything and then you do the rest of your work. Whenever you flip these, don't apply any rules to these terms. Flip them, leaving them what they are. The only thing that's going to change is going to be the negative 3 on the outside is going to become a positive 3. Okay, so I don't like going to the side and having to come down, so I'm just going to come down, y'all. Evaluating -3 on the outside, I flip everything. You don't flip and apply rules at the same time, you just flip. The rule I did there was that little shortcut. Now here you could actually go ahead and change that -3 to a +3. Okay, so I've got to swap up, y'all. Now what we would do is we would go ahead, still working from the outside in, because I wouldn't want to work on the numerator or work on the denominator when there's still something going on around it. That like the 3 on the outside is going to take precedence. Okay, so this is that a over b raised to the m, right? Remember I said there could be any number of terms though on the inside. And what we know is that everything on the top and everything on the bottom is going to get raised to that m, to that power. So in our numerator, in parentheses, we have 4 to the -1, and then raise it to the third power, parentheses y cubed, cube it again, denominator 3 cubed. It's really easy to forget those little coefficients, those little constants. So just make sure that you understand everything gets that power, y'all. Parentheses, cube it. Okay. Now what I notice is I have the rule that states if you have something raised to a power and then raised to another power, you keep your base, keep your variable, keep whatever it is, and multiply your powers, right? Power to a power, multiply your powers. So in my numerator, 4, keep your base, right? Multiply your powers. 1 times 3 is 3. Signs are different, so it's negative. Look at your y cubed. Keep, multiply. Look at your denominator. 3 cubed is just 3 cubed. And then we have x to the -2, and then it's being raised again to the third power. So what you do is you keep. 2 times 3 is 6. Signs are different, so it's negative. When I look here, what I see is that I know I need to make sure that I don't have negative exponents. Like this couldn't be my correct answer. So if something is negative up top, like if the exponent's negative up top, not just the number. Numbers can be negative, not a problem. It's if your exponents are negative. If I have a negative exponent up top, what you would do is bring it to the bottom and vice versa, right? So fraction bar, this is going to come down. This is going to come up, okay? And the signs on the exponents change. X to the 6th, y to the 9th. Those are different. You can't combine them. You can't apply any rule to them, okay? And then in the denominator, we have 4 to the 3rd, and then we have 3 to the 3rd. And that's how this problem ends up getting so big, y'all. See what I can do. X to the 6th, y to the 9th. 4 cubed was 4 times 4, 16 times 4. We got 64, right? These are multiplying. Whenever they're in this exponential form, you don't have to put things in parentheses, y'all. The fact that this 4 has an exponent, when I see another large number, I know that what's happening there is multiplication, okay? 3 cubed would be 3 times 3 is 9. 9 times 3 is 27. And looking at my answer key, I'm trying to make it a little bit easier to write here. Looking at my answer key, what I get, which is what we have here, is x to the 6th, y to the 9th. If you do 64 times 27, you get 1728. So this problem use flipping it, right? And then once we flipped it, we used a power rule where everything got the power. And then once everything had the power, I noticed, hey, I got a few power to a power. Well, power to a power, we multiplied our powers. Then I noticed, okay, well, after doing that, I still have some negative exponents. So those need to move to the appropriate places depending on where they are, where they start. And then after doing that, in the video, I've kind of been like, okay, that's it, you're done. But in the homework, probably have you actually evaluate that. And the answer to the far right corner would be the final answer, y'all. Okay, so this was pretty much it for 12.1 and 12.2. If I look into that one problem and I decide to go and make a video, I'll just add 12.2 exponent rule, combining rules, example video or something, okay? Try to make it as self-explanatory as possible when you read the descriptions. That's it, y'all. If you have any questions, like always, make sure you ask, okay? Thanks. Bye.